Spun concrete light poles tower above our towns and cities, lighting the way. They're actually hollow structures with wiring or cable snaked through the cores. The concrete walls are reinforced by steel, yet these poles or lampposts are flexible enough to bend with the wind and snap back. When it comes to lampposts, the higher the light, the greater the area illuminated. Some concrete lampposts are over 10 meters high. Workers start with the tenon, the part of the pole framework that anchors the light fixture. They've placed two in a mould because they're making two lampposts at once. A worker strings 4 thick steel strands from one end of the long mould to the other, threading them through the tenons and through spiral wire. This establishes the basic framework. A colleague installs zinc boxes for electrical connections. He caps it with a block of rigid foam to protect it when the concrete is poured. The next worker attaches a stress gun to chocks that secure the steel strands. The gun pulls the strands one by one to a specific tension, and they stretch like rubber bands. They'll be pulled even tighter later on. Every metre or so, he attaches stay rings for extra rigidity. He ties them in place with plastic-coated wire. The spiral wire is then stretched around the steel strands and tenons to form the skeleton of the lamppost. The spiral wire will also stop the post from twisting too much in high winds. A crane transfers the long and heavy mould over to the next station and lowers it onto several stands. A hopper now swings into action. It's a travelling concrete dispenser. As it moves on a track, it funnels a special mix of concrete into the mould. The concrete has been made to order, with the customer specifying the colour and strength. The concrete also has a low moisture content. This makes it the consistency of clay and therefore malleable. As the concrete is dispensed, workers pack it around the lamppost steel skeleton. They scoop up overflow and smooth the surface of the wet concrete. One worker then cleans up the outer flanges and applies a non-stick liquid. A crane moves the top half of the mould into position and lowers it onto the concrete-filled bottom part. The team bolts the two parts of the mould tightly together using pneumatic impact tools. They now pull the steel strands to their final tension, stretching them so tightly that they compress the concrete once it hardens. Concrete is much stronger when it's being compressed. The mould is now ready for the spinning machine. It's essentially a series of train wheels. A crane lowers the mould's running rings into the grooves of the wheels, and then it's time for a spin. The wheels turn at 500 RPM, and the centrifugal force causes the concrete to migrate to the outer wall of the mould. The result is a hollow pole with a dense concrete wall. Transferred to a kiln, the concrete steam cures in the mould for about 5 hours. The concrete lampposts are ready for the big reveal. They open the mould and roll them out. At this point, the two posts are still attached. They examine them for flaws and then they'll separate them. All they need now is some buffing up. Here they polish a different octagonal post to expose the pigments in the concrete. The different coloured aggregates in this particular cement mix give the post a mottled, marbled look. An identification tag has also been moulded into the cement with the manufacturing date and the post's height and mass. They test just how far they can take it to confirm the post meets industry standards. They spray an acrylic finish onto some lampposts, making it easy for graffiti to be removed. Even though it only takes about 5.5 hours to make a concrete lamppost, now you know how it's made, I'm sure you'll look at them in a new light.